when we're solving using z-scores, we can actually manipulate the formula around and find any single piece of data in there. And so in this lesson here, we're going to look at how do we manipulate the formula for z-scores and find all the different parts. Okay, so in other words, if we have the z-score, how do we find everything else in the formula? All right, so I'm just going to put the main formula here, divided by sigma. There we go. Look at that, typing blind. It worked pretty good. So there is our formula for z-scores. So now here, this question, the example we're going to take a look at, it says, or it goes through, the average man has a height of 109 centimeters with a standard deviation of 6.5 centimeters. If Tim has a height, or if Tim's height is a z-score of negative 1.23, what is his actual height? So in this case here, we're trying to find that data point. We're trying to find x. So how we do that, and I'm going to manipulate the formula instead of putting numbers in and going through there. So we're going to manipulate the formula is x minus x bar divided by sigma. Okay, so there's our formula. Now we want to try to get x all by itself. So the first thing we need to do is we need to multiply both sides by sigma. And when we multiply both sides by sigma, I'm going to just draw that in there. Okay, so we're going to multiply this side by sigma, and we're going to multiply this side by sigma. There you go, should be a sigma, not a 6. Okay, what we're going to be left with, and we're going to try to do this in nice orderly fashion, is we're going to be left with z sigma, and maybe I'll put a dot there because we're multiplying, is equal to x minus x bar. Okay, so this is what we're left with once we've gotten rid of sigma. So if we multiply both sides by sigma, these ones cancel out, and we're left with this. Now we want to get x all by itself, so that means that we have to add x bar to both sides. That should be add x bar to both sides. That'll get rid of it. Again, the brackets here are actually arbitrary. They don't really need them, so we'll get rid of them. And so what that will give us then is that z times sigma plus x bar is equal to x. So to find our data point, we can do our z-score times sigma, and then add our mean onto there. Okay, z-score times sigma, and then we're going to add our mean onto there. Let's do the example that we have here. What we have is our z-score is negative 1.23. So negative 1.23. And we're multiplying that by sigma, which is 6.5 centimeters. And then we're adding on 179 centimeters, which is the mean height. And that's going to give us x. So right now we've just manipulated it, and we're plugging it into our formula here. When you do that on the calculator, negative 1.23. There you go. Okay, negative 1.23 times 6.5 divided by, plus 179. This is going to tell us that Tim has a height of 171.01 centimeters. Normally, we're going to probably keep that in x equals mistake there. X equals 171.01 centimeters. Therefore, what is his actual height? We would have, let's try to get this going here. Tim's actual height is 171.01 centimeters. Okay, there would be his height. So that is, if we have a z-score and we know the standard deviation and the mean, we can actually find what the actual height is. Okay, so we can actually find what the actual height is. So let's take a look at another one here. And in this case, we're going to be wanting to try to find what is the mean. So we're given a standard deviation. So we're told that bags of chips are packaged to have a mean mass of 7 grams. Sorry, have a mean mass and a standard deviation of 7 grams. So we know standard deviation is 7 grams. We know that one bag of chips has a mass of 254 grams and a z-score of 0.33. So we have standard deviation, the data point, and the z-score. So what is the mean mass of all the bags of chips? Well, in this case here, we're going to need to manipulate our formula. So let's start with our formula here. Z is equal to x minus x bar. Divided by our standard deviation. Okay. We're trying to get x bar here all by itself. And so what we need to do first, let's get rid of the standard deviation. So same thing that we did before, multiply by standard deviation. So z times standard deviation is equal to x minus x bar. And I got rid of the brackets right there. We want to get x bar all by itself, so we're going to have to subtract x from both sides. And again, remember, it's not because we're subtracting x bar, we're not subtracting x. X is positive, and so we need to subtract x from both sides. Or sorry, yeah, subtract x. This is going to be z times sigma minus x is equal to negative x bar. Negative x bar. We don't want negative x bar, so we need to divide everything by -1 or multiply everything by -1. And so what that's going to give us then is, if we multiply everything by -1, we're going to get multiplying everything by -1. So we're going to get -1 this will be negative z times sigma. Sorry about that. Just confused for 1 second there. Plus x is equal to positive x bar. And so we changed, so this term became negative, this term became positive, this term became positive. When we multiply by -1, we can rearrange this here. So if we want to rearrange so that the positive one is in front, we can just go like that. And now we have a positive x in front, and that might just help out a little bit. So this is the changed equation, so we can solve for the mean. Now, to solve for this one here, so if we want to find the mean, what we're going to do is we're going to take our x, which is 254 grams, minus our z-score of 0.33 times our standard deviation of 7 grams, and that's going to equal to x bar. And when we solve for it, x bar is equal to 254 minus 0.33 times 7. And we're going to get 251. So that means that our average is 251.69 grams. 251.69 grams. There we go. Okay, so that would be our average or our mean mass of all the bags of chips. The mean would be 251.69 grams. Okay, so that's, again, if we're given the other 3 pieces of information, we can find that 4th one using this little equation here. This one's to find the data point, this one's to find the mean. Lastly, we want to find what is the standard deviation. Can we solve for the standard deviation? IQ tests are a way to measure the way people think. The average person has an IQ of 100. That's average. There's our mean, right? If Jennifer has an IQ of 120 and a z-score of 1.33, what is the standard deviation of an IQ test? All right, well, firstly, let's rearrange our formula and solve for standard deviation. Okay, so our formula, again, going to write it out again, x minus x bar over sigma. And we're going to try to get sigma all by itself. So the first thing we need to do, again, same as we did before, we're going to multiply both sides by sigma. So z times sigma is equal to x minus x bar. Get rid of the brackets. Oops. Equals, there we go. Okay, we don't need brackets in there. All right, so now what we've done is we put sigma onto the other side. We got it out of the denominator, which is important. Now to get rid of sigma, to get sigma by itself, we're going to divide both sides by z. And so that's going to get rid of the z there. And we're going to get sigma all by itself here. And again, I'm going to put brackets in again, but that's okay. And we're going to divide this side by z as well. And so now we have sigma all by itself. So this is our formula to try to solve for sigma. We can find what is the what is the standard deviation of a set of data. All right, let's solve. Okay, let's do a little question here. We want to find what sigma is. And so we're going to put sigma in there. Sigma is equal to x, which is 120. Okay, so that's the data point we have. The minus the mean, which is 100, which we're given, and divided by our z score, which is 1.33. And so sigma is equal to, let's whip it up on the calculator here, 120 minus 100 divided by 1.33. So standard deviation is 15.04. Okay, so sigma 15.04. Okay, that would be our standard deviation. That's how, again, the groupings that are working that work through it. Now, each of these examples involves using algebra to solve for the missing value. You can use the rearranged function for each situation based on which piece of information you need. So if you want to use you can use each of these functions here, and I'm just going to draw a quick little box around them so that we have all of them there. So this one here is to solve for standard deviation. This one right here is to solve for mean. And this one up here is to solve for a data point. Plus, we have our regular z-score formula that we always have that we can use to solve for z-score. So these four give us a chance to solve for each one of the data points. Okay, so we have a chance to solve for each one of the data, or each piece of it. Okay, so this is the data point. This one here is z-score, put up in front. There we go. This one is to solve for the mean. And this one down here helps us solve the standard deviation. There we go. So that's where each one kind of helps us. I'll put this on this side here as well, so we can find each one of the pieces.